stars in our galaxy over its lifetime. About 1 million out of the billions and billions of Milky Way stars. So where could ET be? And how will we know when a real signal comes through? The SETI team is confident they'll be able to spot any life-changing messages after a dramatic event. Green Bank, West Virginia, July 1996. Signals from outer space were being collected by the huge radio telescopes at the National Radio Astronomy Observatory. The researchers from SETI, the Search for Extraterrestrial Intelligence, hoped they'd be able to eavesdrop on an alien communication, confirming once and for all that we are not alone, the moment of first contact. Although it's a routine procedure, that day, something was different. The SETI team began receiving an unusual signal, a signal that created quite a stir. SETI scientists began to run through their predetermined protocols. Step 1. They moved the radio telescope dishes at the observatory slightly off target, then returned them to their original position. If the signal continued during this movement, then they'd know it's a false alarm from something close to Earth, like a satellite. But if the signal was coming from deep space, then even a slight adjustment to the dishes should cause the signal to stop, then return when the dishes are moved back. That's exactly what happened. The signal had passed their first test. Now for the second. Step 2 is contacting another observatory, preferably on another continent.
Call up somebody at a different radio observatory, somebody who has a different set of antennas, because you wouldn't believe it if you were the only ones to find it. It could be just a bug in the hardware or software here.
But 16 hours after the signal was first detected, and before they could get a confirmation from another observatory, they discovered the source. It was coming from the SOHO spacecraft, 1 million miles away from Earth, currently studying the Sun. A software glitch in SETI's computer system made SOHO's communications appear to be a legitimate alien signal. Despite the obvious disappointment, the event gave SETI Institute scientists confidence that their protocols work, and that when a true alien signal comes in, they'll be able to recognize it and realize that first contact is being made. But they still need to make sure that their dishes are pointed in the right direction, at the right time and at the right frequency, which is no easy task.
So where is ET hanging out? I mean, you know, we could point these things anywhere. Well, we don't know. Obviously, we don't know. But what you do is a very simple strategy. You start with the nearest star system and you sort of work your way out. Right? You start looking in your own backyard first. I mean, imagine looking for, I don't know, for fat elephants. You might start in your own backyard and work your way farther afield. Until finally you either hit an elephant or you don't.
In the years to come, SETI hopes that new space-based technology and missions planned by NASA and the Jet Propulsion Laboratory will help pinpoint attractive targets. These targets are called exoplanets. Planets outside of our solar system orbiting around other stars in the universe. But finding them is not easy.
To discover planets around other stars takes every bit of technology we've got. We use the biggest and fastest computers, and we use the biggest digital cameras you've ever seen. Some of them are 1 billion pixels, not a megapixel, but 1 billion pixels. So with all of that technology brought to bear, we are beginning to find these exciting planets around other stars that, frankly, remind us of our own solar system, of home.
But current telescope technology only allows us to see rough images of huge gas giants like Jupiter, which has a diameter 11 times larger than Earth. We can't yet see Earth-like planets, but that is about to change. The Terrestrial Planet Finder. expected to launch by 2020, will use multiple space-based telescopes, all working together to peer deep into the cosmos for an alien Earth, which might harbor intelligent life.
This would be a gargantuan telescope allowing us to take the first pictures of another Earth around a nearby star, a pale blue dot orbiting a yellow sun. Wouldn't that be glorious?
And the terrestrial planet finder will provide more than just an image.
You not only can see if the planet is bluish, telling you there's water on the surface, the prerequisite for life, but moreover, you'd be able to analyze the light from that Earth into all of its colors, blue, green, yellow, and red, even the infrared, telling us the chemical composition of that planet. And the most exciting prospect is to find a planet that has oxygen in the atmosphere.
But until the terrestrial planet finder system is ready in 2020, SETI researchers will simply have to hope that the stars they target contain a life-supporting planet nearby. Many first contact scenarios depend on much more advanced aliens using incredibly futuristic technology to either visit us, send artificially intelligent probes, or at least beam a big hello message from across the universe. In those situations, we'll just have to hope that they use that old movie line and say, "We come in peace." But what if the responsibility for making first contact falls to us? Are we up to the task? Since our astronauts have only reached the moon, and a manned trip to Mars is still an imposing challenge, the idea of humans visiting other worlds is still the stuff of science fiction. But we do have probes heading off into deep space right now. In 1977, NASA launched the Voyager 1 and Voyager 2 space probes to study Jupiter, Saturn, Uranus, and Neptune. They are now far beyond Pluto, at the very edge of our solar system, and headed for interstellar space. Voyager 1 is farther out, about 9.9 billion miles from the Sun, farther from Earth than any other man-made object. Each probe contains a gold-plated copper phonograph record. Mathematical instructions on how to play the records are printed on them, along with diagrams of scientific principles that are likely to be understood by alien civilizations.
They actually had a medallion that had engravings with sounds of the planet Earth, sounds that you could hear, the location of the Earth in our sector of the universe. Basically a roadmap as to who we are, what we want, and sounds we make, and our location.
The cryptic messages and basic formulas on the probes were chosen by a NASA committee shortly before the launches to give the best representation of the culture, people, and natural wonders of Earth.
As the Secretary General of the United Nations, I send greetings on behalf of the people of our planet.
Hello from the children of planet Earth.
Bonjour tout le monde. Mae Latnia.
Shalom. Hola y saludos a todos.
But these communications also serve as an example of one of the greatest challenges of making first contact. There is no guarantee that they will even understand us.
In the same way that we were able to break the code of Egyptian hieroglyphics using the Rosetta Stone, scientists are faced with the challenge of finding a cosmic Rosetta Stone, something that will be understandable, serve as a universal language that both extraterrestrials and humans will be able to tap into.
The Rosetta Stone offered a passage in 3 languages, 2 forms of Egyptian and also in Greek. The stone was a breakthrough in decoding ancient Egyptian hieroglyphics, one of the languages on the stone. Since the other 2 languages were understood, they were able to decode the 3rd. Such a tool would be needed for extraterrestrial communication.
The usual starting point of an interstellar message, the sort of universal language, the basic building blocks, is to start with mathematical and scientific principles. It seems likely you at least need to know that 2 + 2 = 4.
Mathematics is uniform throughout the universe. I'm a physicist, and one of the greatest thrills I have is writing down an equation for the first time in history, and perhaps on the other side of the galaxy, perhaps there's an alien being writing down that very same equation.
So could the Voyager messages, now billions of miles from Earth, be the